Now that we have our 5-number summary, we're ready to look at a way to determine outliers. This is our first example how we use a measure of variation and measures of center to determine if a data value is unusual. We're going to continue with a 5-number summary to demonstrate. IQR is a measure of variation. So the 5-number summary is a measure of variation, but so is the IQR. And it represents how the middle 50% varies. So we have our range, which is the entire data set, how that varies. Now we're going to look at the IQR and use that as a measure of variation. It is basically the range of the middle 50% of the data. In order to determine if something is unusual, so this is a philosophical thing, we need to first determine what is usual. So to do something, to figure out what's unusual, we need to determine what is usual or common. The middle 50% is an area where we say the data is considered common. Notice it contains the median and a measure of center. So the median is a measure of center. So we're going to use the middle 50% as a way to find outliers. So we have this thing called the 1.5 IQR rule. And one thing we want to emphasize is the IQR, again, is a measure of variation. And will be used like a ruler. Think of it like a ruler to determine distance. So the middle 50% contains the spread of the middle 50%. That's what this IQR is. We're going to say that that spread contains things that are usual, and then we're going to use that to determine what is unusual by doing what? By starting here at one edge of the IQR and then going outside of it. So I'm going to take Q3, add 1.5 times the IQR. So one full IQR and then half an IQR. This will create a position called the upper fence. If your data is greater than the upper fence, that data value is an outlier. And we'll do the same thing here. For the lower part, we'll start at the lower end of the box, of the IQR, and then subtract 1.5 times the IQR, creating a position called the lower fence. So a data value is an outlier if it falls outside these fences. Data is an outlier if it's smaller than the lower fence. Data is an outlier if it's greater than the upper fence. Okay. So let's look at the lower fence for the population data. So right now it's a little bit off screen, but it should be on your piece of paper at the very top. So I'm going to find for my lower fence, I'm going to find Q1, which turned out to be 1.35. Then I'm going to subtract the middle 50%, 1.5 times the middle 50%. The IQR was 5.675 million, but I'm going to write these values here instead of the IQR, which is calculated. Again, I can see it in the upper part of my paper. And this turns out to be negative, I believe, yep, negative 7.3275 million. Well, clearly we don't have negative people. The smallest the population can be is 0. This says is there's no data below this lower fence, so there's no outliers in the lower fence. What about the upper fence? So again, I'm going to start at the Q3 this time as my start. Add 1.5. And again, it's this value right here, this difference, which just I'm going to write as that difference, which was 5.675 million. Okay, so it should be sitting on your piece of paper at top. When I calculate this, I get 15.7675 million. So what data values are outliers? So now we need to look at the data. So this is not going to determine my outliers. This is used to determine my outliers. I know there's no outliers in the lower fence because the lowest value, again, I'm looking at the 5 number summary above my piece of paper, is 0.06 million. Okay, so again, look at how we've done this. Think of Q3 and Q1 as my starting positions. So there's like a little house containing the middle 50%. And then this is the little door that leads outside of that. And we're moving 1.5 times the IQR. This is the lower end of that little box. And we're going to move to the left. And anything outside of this lower fence is going to be considered an outlier. But this is the only game in town. 15.76, 15.76, 15.76, 15.76. I'm grabbing my data. And here we go. 15.76. 12 is right here. 15. Here's the 15. So I'm just abbreviated by 15. This is the location of the upper fence. I'm going to call it UF, upper fence. So that means anything greater than it is an outlier. So this 19.45 is an outlier. Outlier, 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 outlier. An outlier just means that it was extreme. We do not get rid of outliers. We never get rid of data. The only time we would get rid of data is if it was incorrectly measured. Literally, there was an error involved. These are not errors. These are just extreme values within our data set. So all we're doing is labeling these as outliers, but they still remain part of our data set. So what are my outliers? Outliers are going to be, again, this set, 19.45, 21.48, 29, and 39. I forgot what it is already, 51, I think. All these values are greater than my upper fence of 15.76 million. So let's look at the next one. For example, the exam score example. Question 6, let us calculate the upper and lower fence and determine if there are outliers. Okay. So off screen, I have another piece of paper that shows my 5-number summary. Maybe I should write it down here. I think I'll do that. So for the exam scores, we found that my minimum was 0.408, Q1 was 0.776, median was 0.811, Q3 is 0.903, and maximum is 0.974. Great. So now if I want to calculate my lower fence, I need to start here at Q1. And now I keep going to down, further down, away from my median. So we're going away from the median. And I'm going to do this by going 1.5 times the IQR, which is 0.903 minus 0.776. When I calculate that, what do I get? 0.5855. Any value less than this lower fence is an outlier. What about the upper fence? Well, I'm going to start here at Q3. But now I'm going to go greater than. I'm going to go above this number, and it's 1.5, and again, this IQR. But I can start seeing, looking at this is about, 13? And 1.5 times 13 is going to get, and then starting at 0.903 is going to go over 1. So I know there's not going to be any outliers in the upper fence because the most the upper data can go is 1. So that gives me 1.0935. I get no outliers. In upper 25%. Great. So what are the data values? Again, I'm going to use my lower fence. Come over here. And what's it, 0.58? 0.58. So boom, there is 0.58. And these two values, the 0.406, 0.547, these are the outliers. So my outliers are where did this 1.5 come from? So the person who developed this thing is called Tukey. His name was Tukey, and you can look him up. There's a lot of things that attributed to Tukey. One of them that you are familiar with is the concept of data bit. The bit is a word he coined. I think byte is something he coined as well. There was a lot of things developed in computer science that he coined because I think he worked for Bell Laboratories. But anyway, you can look him up. A really amazing fellow. He was a mathematician, statistician, but also worked in many other areas. So I'm going to go back here and just recap here. So the method we're using to determine outliers is called the 1.5 IQR method. Sometimes you'll see books describe this method, which uses 3 times the IQR. And when that happens, this is still being used, but we have a second level. So anything beyond 1.5 IQRs would be an outlier. But if you reach the level of 3 times an IQR, this would be an extreme outlier. Okay, so if you go I'm going to just go Q3. Q3 plus 3 times the IQR. If your data is greater than this data now is considered extreme. Outlier. Maybe something here. So this would be an extreme outlier. Just in case if you use software and you see that pops up.